Today we're doing elimination with a little bit of a curveball. Yesterday it was cute because we always had like negative 2x and positive 2x, or 5y and negative 5y, and they always canceled out because we had one positive, one negative. They had the same values. Today, not the case. So pause if you need to fill in these blanks, but here's what we got. We're going to write both equations so they're in the same format. Get the x's and y's on the same side, get everything else on the other side. Decide which variable, x or y, that you want to eliminate by looking at the least common multiple. Not necessarily least common multiple, just a common multiple. We'll see. Then multiply the equations by a number so that the coefficients are opposite LCM of each other. You want positive 12y, negative 12y. And then you use the addition rule like we did yesterday to solve. So here we go. 3x minus 4y equals 7, and 2x minus y equals 3. So let's go ahead and stack them on top of each other, because that's usually how they're given to us. It would look like this. 2x minus y equals 3. There we go. Now, the x's, they don't match up. Neither do the y's. 2 and 3. We could think of, what do they both go into? They both go into 6. So we can make them both 6x, or 6x and negative 6x would be ideal. The 4y and negative y can both go into 4y. And the nice thing about that is we don't have to multiply that first equation. We do want one to be positive and one to be negative. So if I want this to be negative 4y, you could just multiply it by 4. But we want a positive and a negative. We already have a negative 4y up there. It's an easy fix. So we're just going to multiply that second equation by negative 4. The whole thing. Negative 4 times 2x is negative 8x. Negative 4 times negative y is positive 4y. And negative 4 times positive 3 is negative 12. I'm going to rewrite that first equation underneath this. 3x minus 4y equals 7. At this point, it's exactly like we did yesterday. Our y's are going to cancel out. So we have negative 8x plus 3x. That's negative 5x. 4y plus negative 4y, 0y. And negative 12 plus 7 is negative 5. So our equation is negative 5x equals negative 5. Now we could go ahead and divide both sides by negative 5, and you get x equals 1. Still need y. You could go with the original two equations, or you can go with the one after you multiplied it. I usually recommend the first two just because they're smaller numbers typically. And like I said before, maybe I've made a mistake in the multiplication. So if I put it into one that I changed, maybe I'm putting it into an equation that I made a mistake on. So go with one of the original two. Let's say I went with the first one. 3x minus 4y equals 7. Now 3 times 1 is 3. So we have 3 minus 4y equals 7. We could subtract 3 from both sides. That would give us negative 4y equals 4. And then we could divide both sides by negative 4. 4 divided by negative 4 is negative 1. So we write it as a coordinate. 1, negative 1. Try it out, dude. Pause it here. Check it out. Now this one you don't need to write as a coordinate because it's a's and b's. That's fine. Otherwise, write it in alphabetical order as a coordinate. So I'm going to start going over it now. Let's see. 3a minus 7b equals 6. So let's say we want the a's to cancel out. I need a number that 2a and 3a. Oh, this isn't even a you try. This is just an us do. We need a number that 2a and 3a both go into. 6. That's the smallest number they can go into. Even if you can't figure that out, you can always, 100% of the time, just take the numbers in front and flip them. Top by 3, bottom by 2. And you could do that with the b's as well. Top by 7, bottom by 6. 100% of the time you can do that. But keep in mind, we do want one of these to be positive, one of them to be negative. Easy fix for that. Currently, they're both positive a's. Boom. If we multiply by negative 2, it'll switch it to a negative. So the top equation times 3. 3 times 2a is 6a. 3 times 6b is 18b. And 3 times 4 is 12. The second equation times negative 2. Negative 2 times 3a would be negative 6a. Those are going to get eliminated. That's the whole reason we did it. Negative 2 times negative 7b is going to switch it to positive 14b. And negative 2 times 6 is negative 12. So now 6a minus 6a, 0a. 18b plus 14b is 32b. 12 plus negative 12 or 12 minus 12 is 0. Divide both sides by 32. 0 divided by anything is 0. So b equals 0. We still need a. Go with any of the equations. You got 4 equations you could choose from. I'm going with the first one, the 2a plus 6b. So 2a plus 6 times 0 equals 4. 6 times 0 is just 0. So we would just have 2a equals 4. Divide both sides by 2, and you get a equals 2. And again, it's not x and y, so you don't have to put it as a coordinate. Or you could, in alphabetical order, it would be 2, 0. Whatever you want to do there. All right, we've done 2. Why don't you try this one? Now, both of them require us to get the u's and the v's on the same side. So we'll go ahead and start that together. We're just going to add the 2u to the other side. So we would have 2u plus 4v equals 8. And on that one, we would subtract the 5u. We'll just go ahead and do this one together. If you look at the u's, we have 2, we have 5, they both go into 10. You can just take the numbers in front and flip them. And I would probably do that because we already have a positive and a negative, so that part's handled. Otherwise, do the v's. 4 and 3 both go into 12. You could do the top by 3, bottom by 4, or negative 4. But I'm going to do the 5 and 2. So we're going to do the top by 5, the second one by 2. So 5 times that whole top equation will give us 10u plus 20v equals 40. The second equation times 2 would be negative 10u. Those will be eliminated, plus 6v equals negative 26. The u's eliminated. V is 20 plus 6 is 26. 40 minus 26 is 14. Wow, that seems like a sloppy decimal. Great. So we'll divide both sides by 26, and we'll keep it a fraction. Those are both divisible by 2. That would give us 7/13. That's going to be really fun to substitute back in. All right, let's go with the first equation, the 4v. Oh, I'm solving. Yeah, that's good. 4v equals negative 2u plus 8. So 4 times v, which is 7/13, equals negative 2u plus 8. All right. So 4 times 7/13, that would give me 28/13 equals negative 2u plus 8. Now we're going to subtract the 8. Man, this is a brutal problem. And this was for you to try. Oh my goodness. We're going to have to subtract the 8, right? Now we're going to have some fraction subtraction. 8 is like 8 over 1. So we have to do 28/13 minus 8 over 1 equals negative 2u. Whew! We got to get a common denominator. So a common denominator could be 13. Oh boy, oh boy. 28/13 minus 8 times 13, 80 plus 24 is 104. If we do 28 minus 104, 30 plus 2, I think that's, should be negative 76/13. Wowza. All right, negative 76/13 equals negative 2u. We're going to have to divide by 2. Negative 2. Divided by negative 2. Now that's kind of strange. We have a fraction divided by negative 2, but we're going to do the old keep, change, flip. We're going to keep our first fraction. We're going to change to multiplication, and we're going to flip that second fraction. Now negative 2 is negative 2 over 1, but if we flip it upside down, it'd be times negative 1/2. If we simplify, 2 goes into 76 38 times. So we have negative 38 times negative 1, that's positive 38, over 13 equals u. Now that was ridiculous. We have 7/13 and 38/13, which is correct, but goodness gracious, that was terrible. That had every single stop from our pre-algebra days. And here we go. We're just going to do example 3, and then you could try this one on your own, but I'm running out of time on the video too. So we're going to get this negative 5y to the other side by adding it. So we'd have 3x plus 5y equals 6. We got to get a common multiple. So let's say we went with the x's. We could do negative 4x times 3, 3x times 4, and they would both become 12x and negative 12x. So that would give us negative 12x plus 6y equals 15. And this one would give us positive 12x plus 20y equals 24. If we add those up, x is gone, 26y equals 39. These are both divisible by 13, which would give us 3 over 2, or let's just call it 1.5. We do need x. Let's go with this first one. 3x equals 6 minus 5 times 1.5. Now 5 times 1.5 is negative 7.5. 6 minus 7.5 would be negative 1.5. And if we divide by 3, you get negative 0.5, or negative 1/2. So our coordinate here would be negative 1/2, or negative 0.5, and then positive 1.5. That's how we do it quick. Hopefully you can try out that second one, but my next class is about to start, so I got to cut the video there.